IGCSE Computer Science, Syllabus Statement 1.4D, Show Understanding of the Use of Encryption. Alright, so we looked at encryption really briefly in the last video. So what is encryption? Well, encryption is used to protect data in case it gets hacked. And although it actually doesn't stop hacking, it can make the data meaningless to the hacker. There are two types of encryption. There's symmetric and asymmetric. And yeah, we'll be looking at these two today. And yeah, now the thing I was going to say in the last video was, I was going to say asymmetric encryption is pretty hard to actually understand. Like, it took me a couple of hours to understand it fully before actually making this video. Stayed up until like 2 making this, like researching this, and like, oh, what is this? How does this? All right. So yeah. What I've also done is, for asymmetric encryption, we'll look at the actual process, and then we'll actually see this in a diagram as well, because I think the diagram helps to understand how it works. So we'll start with symmetric encryption. So symmetric encryption uses a secret key, which can be a combination of characters. Alliteration. Can be a combination of characters. This key can be applied to a message, which will make the message unreadable unless someone has the decryption key. One key is needed to encrypt the message, and another one is needed to decrypt the message. This means that the sender and receiver must have the same encryption and decryption key. Now, you may guess that this poses a problem. Because, I mean, like, in order for both sender and receiver to have the keys, like, they're going to have to send it to each other somehow, and what the hacker can do is intercept the sent key and use it to decrypt the data. That's not good, is it? But there is a way in which both the sender and receiver have the required key without having to send it. So here's how it works. So sender uses an encryption algorithm and chooses a value. So x equals 2. And x is secret. Receiver uses the same encryption algorithm and chooses a value, y equals 4. Y is secret. So x is secret to the sender, y is secret to the receiver. X is put into a sample algorithm. So 7 to the power of x mod 11. So 7 squared mod 11, which gives 5. And y is put into the same algorithm, same simple algorithm. So 7 to the power of y mod 11, 7 to the power of 4 mod 11, which gives 3. So what happens here is this value is sent to the receiver. So 5 is sent to the receiver. This value is sent to the sender, so 3 is sent to the sender. So then this new value, which is sent, replaces 7 in the algorithm. So it would be 3 to the power of x mod 11. So it would be 3 squared mod 11, which gives 9. So what the receiver does with the sent value is it replaces 7 in the algorithm, just like the other one. And so it's 5 to the power of y mod 11, which gives 5 to the power of 4 mod 11, which gives 9. So as you can see, both of these values are the same. So the sender and receiver have the same keys without having to actually send the keys. So here's how encryption algorithm works. You have a key and you have plain text. Using the key, you put the plain text and the key, that is, into the encryption algorithm. And then you get ciphertext, which is the encrypted text, which needs to be decrypted in order for the data to be understood by the person, or the hacker, or whoever's getting it. So that's pretty much how it works. So asymmetric encryption is a little bit trickier to actually understand, as said. So this is how it works. So we'll go slow. We'll just try to understand this. So asymmetric encryption is a more secure encryption method. It uses a private key and a public key when data is transmitted. And this is how it works. So user A uses a symmetric key to encrypt the message. The symmetric key itself is then encrypted using the public key, which is known to both users A and B. User A sends the message to user B over the internet. User B decrypts the symmetric key by using their own private key. The decrypted symmetric key is then used to decrypt the message sent. Now this is a bit like, you might read this and say, what? What is this? Well, that's the tricky part. The thing is, the public key is shared with both users A and B. User A has a public key, and user B has a public key. So what happens is user A encrypts the symmetric key using the public key, so basically B's public key, so that when it's sent, once it's encrypted with B's public key, B can use its private key, which is known to only itself, to decrypt it. To better see this example, let's take a look at this. So this is a line. This is meant to be sort of the barrier between A and B. So we have user A and user B. So user A has a private key, only known to itself, and user B has a public key, known to both A and B. And B has the same thing, a private key to itself, and a public key shared between the two. So this is what happens. So A wants to send a text message to B. So there's a plain text and a symmetric key. What happens is, it goes through an encryption algorithm and so on, and ciphertext is produced. What happens then is the ciphertext gets sent, but also the symmetric key gets encrypted by using public key B. So I know I should have done this, but I just wanted to make it clear that symmetric key is encrypted by the key known to both A and B to produce the encrypted key, which is, did I do something here? Yeah, I did. Let me just go back here. Sorry about that. It's the encrypted key, which is sent to B. So ciphertext and encrypted key are sent to B. So what does B do now? This is what B does. The encrypted key that it gets sent, it has to decrypt it in order to decrypt the ciphertext. So it gets the encrypted key, decrypts it with the private key B, which is only known to B, so no one else can decrypt it. Basically, the thing is, A can encrypt anything using B's public key, but can't decrypt it because it needs the private key to decrypt it. That's pretty much the idea of asymmetric encryption. Trust me, if this seems hard to you, this isn't the hard part. The hard part is when hashing comes into it, and that's when people are just like, what is the difference between hashing and encryption? How does hashing work? How does that even make sense? Well, we'll try to go slow, and actually hashing is going to be covered in the next video, because hashing is more to do with authentication than encryption. But this video and the next video are linked, so you should probably watch this one, and then the next one, like, right after. So then, once it's decrypted, the symmetric key is, yeah, so this is, symmetric key is, well, the encrypted key is decrypted, and that happens. Yeah, so it's decrypted, pretty much. Then the ciphertext is decrypted using the symmetric key, and then the plain text is produced. And that's pretty much how it works. Any confusion, just go back to whenever I started this. Or look online. Either way, it's fine. So, to increase security, the encryption keys are often generated by a hashing algorithm. Oh, here's the hard part. A hashing algorithm is different to an encryption algorithm. Did I just say algorithm? Algorithm. A hashing algorithm takes a message or key and then translates it into a string of characters, which are almost impossible to break. Now, here's the thing. You can't dehash a hashed, hashed data. You can't, like, simply dehash it somehow. It's like, once you hash it, it's done. So, you might be wondering, oh, what's the point of doing this? Well, again, it's going to be covered in the next video, but And then we'll see how it increases security as well. So yeah, that's pretty much it.